Future Homes, Concepts and Technologies. Hello and welcome to today's webinar. My name is Keira Proctor and I'm the Managing Director of the A. Proctor Group Limited, and this is the 17th webinar in our series that's been running since April. You can go back and review the whole series right here on our YouTube channel or by visiting our Learning Hub at www.proctorgroup.com. You can also use our Learning Hub to request CPD certification, book follow-up virtual meetings with our local team of advisors around the UK, or order sample packs for the products and systems covered in each webinar. Today, we're going to discuss the future of housing and construction and look at some of the concepts and technologies that will shape these developments. We're going to begin with a special guest presentation from Professor Sean Smith, Director of the Centre for Future Infrastructure at the University of Edinburgh, who will cover some of the key concepts and insights driving developments across the industry. We'll follow Sean's presentation up with a rundown of some of the key technologies of systems that will play a critical role delivering fabric performance changes. And finally, we'll have our usual Q&A session, where Professor Smith will be joining our team of technical experts to take your questions. So now we'll hand over to Sean to begin today's webinar.
Hello everybody, and thanks very much to the Proctor Group for the opportunity to come and present today on some thoughts. It's a short period, 20 odd minutes, so it's a short period to cover many things, so I won't cover everything, but I hope you'll find it useful in terms of some of the thoughts around future construction insights. Today I'm going to cover a number of things from the future housing requirements from local to global. We're going to talk briefly about the green hydrogen revolution, which is currently underway. The spectrum crunch, which some of you may have heard of, and some of the new technologies to come, such as Li-Fi, and how we'll be incorporating this into buildings and assets in our homes of the future. The building asset monitoring and the role of digital twinning in future sensors, which is becoming really interesting and really starting to take off. The scale of energy efficient measures, which are en route, and these are definitely coming. They're definitely going to happen. So it's useful to plan and look at that route map of what's coming. The mixing of terms, net zero, carbon neutral, and zero carbon, we'll briefly touch on that. And then finally, some of the areas that we currently do just now in the construction sector, our operations, our delivery, our products, which actually, in fact, wouldn't be included in some of the net zero requirements of procurement by local authorities that are us just now. And as a result, do we need to make sure that we, instead of just focusing entirely net zero, which then might get rid of some of the fantastic or dissuade people from undertaking some of the fantastic work they're doing in materials and other areas, to make sure we still keep that momentum going, and then we include it under Horizon Net Zero type approach. Well, first of all, the world's population in the next 80 years, it seems a long way away, but literally it starts as of tomorrow, so to speak. The next 80 years is not 80 years' time, it's actually over the period, will increase by 3.5 billion. A huge, huge population rise. Roughly about 40 to 38% of the population growth that we currently have. And in addition to that, because people are also living longer, there isn't that same cyclability of homes coming back onto the market. So when you take the population growth to come over the next 80 years, plus people living longer and the lack of recyclability of housing coming back onto the market, collectively it's roughly 2.1 billion new homes will have to be built in the next 80 years. To give you a sense of scale, that's equivalent to building the whole of Europe 7 times in the next 80 years. In England and Wales, when we look at that, and then by 2030, that's just the next 10 years, roughly about 2.3 million homes will require to be built, and that's equivalent to building the whole of Yorkshire and the Humber regions all over again. And in terms of Scotland, Scotland's new housing need roughly will be about 260,000 new homes in 10 years' time by 2030, but that's equivalent to building the whole of the city of Edinburgh again. Green hydrogen, moving on, is really starting to take off, and we've seen significant investments coming in to this area just now, both from utility companies and also oil and gas companies, with major global companies switching investment, particularly into green hydrogen. It's also useful to know your hydrogens. So quite a bit of the hydrogen we see today is known as grey hydrogen, which splits the natural gas into CO2 and hydrogen, but unfortunately still emits the CO2. Blue hydrogen, which has been also gathering some pace recently, where the residual gases are then stored or reused. But green hydrogen is the one that most people are favouring, because then in green hydrogen, we split the water into hydrogen and oxygen by electrolysis. And that's the electrolysis of the electricity is powered by wind and sun, so it's using renewable energy. Goldman Sachs projected that $20 trillion future global market will be the value of the hydrogen sector, with the predominance of that being green hydrogen. And for the UK economy by 2050, it'll be worth £320 billion. And one thing we've all noticed with the COVID era, and we're all working from home and various other changes, is that we're all utilising the internet and Wi-Fi and various other things far more. And it's amazing how far it's come. You know, the Wi-Fi actual development has been over a period of about 30 years, of which the vast majority of the infrastructure and other things was in the last 10 to 15 years. But it's amazing. You look at internet users in 1995, there were 16 million. Now, 24 years later, there's 4.8 billion. In 2009, 0.7% of all tablet use was by, internet use was by tablets or mobiles, and now it's 53% today in 2020. So year on year, it's grown, and of course this year it's likely to be, whilst these are forecasts of exabytes on that blue graph you see there for the coming years, the red bar assumes where it could be by the end of this year in terms of the growth and use of Wi-Fi. The problem is there's only so much effective bandwidth or spectrum frequency which we can use, and that's getting pretty full. And it's known as the spectrum crisis or the spectrum crunch. And with the onset of COVID and our adaptation and changes, that's also then led to us using a lot more of the Wi-Fi and internet far earlier, in earlier time periods than in the coming years. So in which case the spectrum crunch or spectrum crisis has come forward a number of years. In addition to that, sadly, some people utilize, as NetScout identified, they identified it with the opportunities of cyber hackers and others. They've utilized the downturn in COVID to also maximize the number of attacks. And in so the first half of 2020, there were 4.83 million attacks in terms of cyber areas. And the groups that they tackled were e-commerce and healthcare, educational services. And it's important because part of that great utilization or absorption of our bandwidth is coming from these hackers and people who are actually utilizing and setting up these emails that create scattergun and other things to then absorb more internet use. So it is really quite considerable, and there's a 47% increase in average broadband use in Q1 of 2020 versus 2019. And in May 2020, in some areas, it was up 70%. So the good news is we shouldn't panic too much about Wi-Fi, because right around the corner, and I mean around the corner because it's been 16 years in the making, is Li-Fi, which is short for light fidelity. This is wireless communication technology which utilizes LED lighting to transmit data and position between devices, effectively wireless. As a result of that, and with the speeds that can be achieved, it has attracted a lot of attention, and you can use it in all sorts of settings. So Pure Li-Fi, based in Edinburgh, for example, has now had over 200 project trials in over 20 countries. It's seen also not only as a complement, it could also replace in some areas Wi-Fi, but it's more a complement to provide super fast speeds, reduce some of that spectrum crunch that's coming. It's not limited by the spectrum crunch, which is good. It improves security. It doesn't pass through walls, so we can see in the future more people in their homes where they have a home office probably wishing to introduce Li-Fi into the room via their LED lights for improved security. It uses less energy, and it's actually less costly, and it's more easy to deploy. And the reason I raise this is because in 2021, the Li-Fi global standard will then be readied and published, and that will allow all the major companies who are working with this Li-Fi global standard to then move together as one. And when you have that common language approach and synchronicity between the different companies, that helps accelerate its use and adoption. Moving on to digital twinning, which is really gathering pace, particularly for the future of building asset monitoring. Its interlinks with building information monitoring, and the future potential of sensors is really quite exciting, both in energy, building occupant use, and various other features within our buildings and also our infrastructure. Digital building twin needs to be able to associate and connect a building's design and also its utilization, preferably in a single model. and that mimics and also predicts the building's operation and performance. The one thing I would say is that if we use entirely prediction models, we know that part of the current energy performance gap is because some of the existing prediction models and assumptions we've made in the energy performance of buildings were not correct, or the assumptions then increased, and the variation of our assumptions in our energy performance gap analysis then increased that uncertainty. So the good news is, because of the reduction the cost of sensors in this next slide and the real-time information which we can now provide, what we will foresee is future housing associations, local authorities, commercial building operators, people who run estates for various buildings, university building estates, NHS, are going to integrate the full digital models of their buildings. They'll have real-time energy utilization monitoring. And in addition to that, the potential is with the increased use of in situ sensors, because costs are rapidly coming down, you can now create an accelerated action plan plus the optimization of your decision-making in the buildings or infrastructure's operation. And this is where digital twinning could take us in the future, which is very exciting. With COVID, there's been lots of changes, as you may be aware. And of course, the lack of people going into work because they're working from home is creating an adaptation and also a requirement for city authorities to think about how they adapt and renew their city centres. In addition to that, we have what is the growth in the potential of 20-minute neighbourhoods, which are in suburban or other parts of the cities, where people feel that they have access to and can live fairly sustainably within their own neighbourhood within a 20-minute walk or cycle, and that all of the facilities and services are there, and particularly more so if people can do also home working. So one of the things I just would like to raise, and it's an area that we're going to be looking at Edinburgh, is the potential utilisation of gap sites within future 20-minute neighbourhoods. When we're looking at a 20-minute neighbourhood plan, what are the potential gaps? If there are gap infill sites or regeneration sites, how do you align the 20-minute neighbourhood aspirations with the future utilisations of those gap sites? And also the integration with transport needs and also the amenities. And it's all sorts of things that could be changing. For example, nursery provision locally, because people are no longer going to their office as much, they're actually working from home. And in fact, they would rather use the nurseries which are close to the home as opposed to the one that was near the city centre, near their office. So in terms of that, we've also got changes to the nighttime and city hospitality and culture factors to come too. With our future buildings, well, there are changes of uses coming, and we know from the banking sector between 2003 2008, the huge number of banks that then built new buildings, moved into different or brand new Category A buildings, and that left a huge number of office buildings and other things that came up for refurbishment or change of use. And we see the same going forward again. So in likelihood, if this is the case, then be aware. It's very useful to look at. Look out for the opportunities for refurbishment towards net zero. Before you even touch the building that you're going to convert or for change of use, do a sound insulation test first. Before you put any holes in walls or floors, do the sound insulation test. This will avoid over-specification. It allows you to assess the existing sound insulation requirements, whether it be for domestic or non-domestic. And the other feature is where some are going just now with office conversions. And there we've seen entrepreneur Zhu Weiping giving forward their plans for the east of London to turn 20 offices for 2,000 individual pods. So really quite exciting, different changes to come. I'd like to spend a few minutes, if I may, on the future and timeline of energy efficiency measures. There is a lot of activity come over the next 30 years, but specifically in the next 15 years. And so I've put together here a small timeline of some of the changes which are occurring across the UK, whether it's in England or Scotland or Wales, and some of the features around the targets around net zero. The top half of the line and the boxes refer more to domestic properties, and the lower half below the timeline refers to general policies or non-domestic buildings also. Whatever happens, there is a huge amount of positive work to come in terms of conversions, change of use, energy retrofit measures and energy efficiency measures, and the utilisation of low carbon and renewable technologies on the existing stock. And one of the earliest targets that's been set by anywhere in the UK by a local authority is Edinburgh Local Authority and Glasgow Local Authority, which have set a 2030 net zero target, which is a tough ask, a lot of activity to be done there, and it's suspected that many other local authorities may pull forward their targets also to move towards a 2030 as opposed to a later period. Now, mixing of terms net zero, carbon neutral, zero carbon. Net zero is not the same as carbon neutral in the full sense of net zero. Part of net zero is similar to carbon neutral, but not all. So just be careful. Carbon neutral has an accepted international PAS 2060 document guidance, which is really useful, very helpful to everybody. However, net zero does not. So of course, many governments and others have given the policy of aiming for net zero, but actually the definition of net zero and how we measure and calculate and assess any standardized format for net zero is not yet in place. So in the interim, quite a few people will adopt the carbon neutral approach until such time as the net zero is fully ready, but with the ambitions to moving into net zero. There are 6 or 7 different areas of net zero to consider and different types of net zero targets. You might consider, or your client may consider, just net zero operational. They might look at construction and operational. They might look at a science-based target, an SBTI, which is slightly or certainly more onerous than net zero operational, just construction. It goes into the full embodied pathway and also the third sector and the third avenue of where you're sourcing materials and your supply chains are sourcing materials. Then there's advanced net zero, and also beyond net zero, where you become net zero negative. Perhaps you'll offset your greenhouse gases. This isn't always accepted in all of the schemes, so just be careful. Some very positive news in the sense that because the governments have not moved quick enough and the international standards committees haven't really been moving as fast as industry would like, and given that net zero and climate emergency is so important, the good news is that the former governor of the Bank of England, Mark Carney, working with over 50 major companies around the world, is looking to establish a succinct and standardized, uniform and trusted, robust approach towards carbon offsetting and also the calculations of carbon. And this is incredibly important when carbon offsetting comes into play and how this is assessed. Finally, just to mention that be careful if you claim carbon zero. The Advertising Standards Authority in 2011 decided that a company which had actually advertised their products to be zero carbon was incorrect and misleading, because in actual fact, it had in fact utilized carbon processes during the manufacture and also its transport, and therefore could not advertise itself as being carbon zero. We need to maintain the net zero momentum, and that's important, but we have a bit of a problem. Whilst we're waiting for others to agree carbon calculations, definitions, and what's to be included or not with the numerical assessment, we might lose the opportunity to crack on with the existing good practice. For example, I've said to a few organizations that the work they're doing in off-site construction and waste reduction isn't actually included in some of the net zero requirements. So in some cases, 1 or 2 organizations have been saying, well, why are we doing all these great sustainability, environmentally friendly things if it's actually not going to be included properly within net zero? So my suggestion is that we maintain the kind of net zero momentum we would like to get to, but could we introduce an interim framework now that allows us to capture all of the great things the industry is doing, which I call horizon factors, their off-site construction, our design for manufacture, the design for future disassembly that will support our future generations in the material assets of buildings and infrastructure they will inherit from us in 100 or 200 years' time, these horizon factors, our circular economy approaches, and also sustainability. So in essence, by involving these in Horizon Net Zero, there are a number of benefits towards a future carbon legacy, as I've outlined here in this slide, the various bullet points. And now taking this forward into a calculation, we could currently, for example, look at net zero factors for calculation of our carbon emissions equivalent for net zero construction and our upfront carbon leading up to that, both for new build, refurb, and operation. So we can actually produce now the potential reporting outputs for a numeric carbon value. But there are many other things that we do in estate strategies, our building and other operational strategies, which also support legacy factors, which may not currently be, as I've mentioned before, included in net zero. Our sustainable sourcing of materials, designing for future disassembly, utilization of off-site, utilization of digital twinning, and various other features, incorporation of renewable energies. These are all playing a key part, but may not yet be included in carbon calculations as yet for net zero. Hopefully they will be fully and be standardized in the future. So my suggestion is that we still continue on net zero where we can, and we try and keep the momentum going in all of these horizon factors we're doing. And then when at such time in the future we can then calculate all of this more effectively, then we could then almost backdate and look what were the carbon savings of that time. Now we know the calculation assessment process for all these great things we've done over the coming years. So finally, just embedding this approach, we can calculate net zero carbon operations. We then add the net zero carbon construction. We embed our horizon factors in our procurement and our design approach and in our build and operational approach. That builds up, it gives us horizon net zero. It gives us some time whilst those around the world in international standards are readying and standardizing what will be the zero embodied carbon approach. And when that's ready, then we move into that net zero embodied carbon approach without fear of legal complications because of definitions that weren't set or calculations that weren't set. And we first of all go after our carbon negative in new build beyond that, and then our carbon negative in existing buildings. All of this helps in that timeline to reduce by 2040, 2045, and 2050 our carbon. Thanks so much indeed. I'm sorry I've run through so many different things, but I hope it's been useful and it may spark some thoughts and interest. Thank you very much.
First of all, many thanks to Sean for putting his thoughts together for us. And to follow on from that, we'll now take a quick look at how upcoming changes to the building regulations will help move housing towards a lower carbon future. In 2019, the UK government in its spring statement outlined a commitment to introduce a specific future home standard before 2025. This was to future-proof housing practice and provide for a structured roadmap towards decarbonising the UK housing sector, which currently accounts for around 20% of CO2 emissions. The intention was that these changes would get underway this year with the introduction of the 2020 edition of Part L in England and Wales, which acts as an intermediate stepping stone towards the introduction of the 2025 standards. As with many things this year, however, it looks likely that the timescales may slip a little. There are a number of aims driving these changes. The first is to move the built environment away from fossil fuels and towards a more grid-electric-based approach, which is more easily moved towards decarbonisation without directly impacting homeowners. The second is to move the skill base, common practice and supply chains of the construction industry towards this. For example, currently over 1 million gas boilers are installed per year, compared to 20,000 heat pump systems. So immediately swapping these systems would not be practical in production capacity terms, never mind when we factor in the availability of qualified installers. Finally, the consultation proposes specific measures to address the performance gap between as designed and tested, or ADT performance, and as built-in service performance, or ABIS. Regular viewers of our webinars may remember that these concepts have appeared in the 2020 revisions of BS 5250. And the Future Home Consultation expands this further by considering verification and test methodologies to ensure that the specified products and systems are used correctly and they perform as intended by designers. So, what might the specification of a future home look like? The 2020 Part L consultation outlines 2 approaches under consideration as an interim step, with both aspects likely to form the basis of the 2025 standards. Option 1, referred to as Future Homes Fabric, proposes a 20% improvement over current Part L standards for CO2 emissions achieved through a fabric-first approach, with insulation, glazing and airtightness specifications brought to the forefront. This specification may still use gas boilers, but supplements by technology such as wastewater heat recovery. Option 2, Fabric and Technology, is less onerous regarding fabric standards, but places considerably more emphasis on low-carbon heating, such as heat pumps, renewable energy systems like PV, and even systems such as distributed district heating networks in higher density areas. This would deliver a 31% reduction in emissions over Part L 2016. At an estimate of £4,847 per home, the Fabric Plus technology approach increases the build cost by almost double the increase of Option 1, but delivers substantially greater savings on energy bills at £257 a year compared to £59 a year. It is also proposed to remove fuel factors from assessments, reflecting that grid electric heating now has lower carbon emissions than gas heating. Shifting housing to more electric heating, both via heat pumps and less efficient direct heating, also allows the continuing efforts to decarbonise grid generation, to reduce the carbon emissions of housing without affecting homeowners directly. Whilst the U-values and airtightness levels in the Part L 2020 consultation do not advance far beyond the current backstop levels, these are more subtle changes which show the intention is not so much to push the existing methods further as to alter the range of approaches used towards decarbonising housing. Combining these approaches gives us an idea of where the 2025 specification may be heading, with near passive standard fabric insulation and advanced low-carbon systems. However, the standard is not expected to be overly prescriptive beyond setting backstop levels, leaving the way clear for innovative approaches to meeting the requirements. We've covered the design and technology used in passive and low-energy homes in a previous webinar, so if it's of particular interest, you can go back and check that out here on our YouTube channel. These specification improvements only go so far though, and ensuring that as-built performance both meets the design spec can be accurately assessed is increasingly important. As performance levels increase, the tolerances of materials in installation become tighter, meaning any installation problems may have a significant impact. The proposal therefore includes measures to ensure that not only minimum build quality standards are achieved, but that the specified products and systems are used correctly. Any changes to the specified systems would therefore require reassessment to ensure the effect of the changes on design are accounted for. By paying closer attention to achieving these standards, the draft documents aim to increase cross-disciplinary understanding, ensuring everyone involved in a project, both on and off-site, are aware of the implication of their design and workmanship. The principal build quality issues identified are insulation gaps, thermal bridging, and several aspects of air tightness, and steps are outlined to mitigate each through a combination of installer training and awareness, good design and detailing, and finally, appropriate usage of products and materials. Insulation gaps occur where poorly fitting insulation boards allow a significant degree of convective airflow through gaps between adjacent boards, and between boards and surrounding structures. This airflow effectively bypasses the thermal insulation, leading to a shortfall in energy performance between the in situ energy use compared to design values. Whilst it's tempting to think of this as purely an installation issue, steps can be taken at design stage to reduce the potential for installation problems to arise. Using continuous layers of insulation and sizing areas that cutting of boarding is minimalizes can dial out problems before they arise. Ensuring materials are specified appropriately can also avoid situations where a contractor must work out how to fit a square peg into a round hole, often with little guidance as to the implications. Thermal bridging, by contrast, is largely a design problem, where ensuring insulation layers are continuous and no parts of the heated envelope are left uninsulated happens mostly on the drawing board. In this case, the primary issue is ensuring that other parts of the structure are able to accommodate a layer of insulation. Whilst features like foundation and floor zones are typically fairly straightforward to adequately insulate, door and window openings can present a much more challenging scenario. Good material choice is often the key to achieving an effective thermal bridge design, where balancing thickness, thermal conductivity, structural and hygrothermal properties is critical. Systems such as our Space Therm aerogel range can allow thermal performance to be boosted at any point of the building envelope with minimal thickness and without trapping moisture. It's also available as a Euroclass A2 rated variant for use in fire-critical situations. The effects of material choices can also be less obvious. For example, using a non-ventilated roof construction with an underlay such as our roof shield allows insulation to be packed fully into the eaves of a roof, extending over the wall head without any concerns regarding compromised airflow. The consultation proposals around airtightness cover 4 areas: incoming services, airtightness of structure, airtightness around openings, and internal service runs. This is a topic we've covered fairly frequently in our webinar series so far, and a lot of the build quality issues identified are very familiar. As fabric insulation levels increase, minimising this air leakage becomes a bigger influencing factor on the overall energy performance. Already, homes contain a huge variety of services and other penetrations. Smart controls, systems monitoring, automation, AV and networking systems will only increase this, making robust solutions for integrating building services without compromising airtightness is critical going forward. This is particularly true in high-density developments, where using Wi-Fi for everything may not be ideal due to interface concerns. As with a lot of these build quality issues, the solution of sealing the surfaces is deceptively simple, but in practice it requires careful design to minimise air barrier penetrations, and well-trained installers afforded the time and the space in tight schedules to do the job right. Here again, though, exists some technical solutions that can design out a lot of these problems if correctly executed and integrated into the design at the correct stages. Moving the airtight layer well away from the service zones by using a membrane such as our vapor-permeable wrap-tight air barrier provides a durable and robust solution to ensuring design airtightness targets are met. Solutions like wrap-tight can be applied to most types of base construction, from traditional timber frame to high-rise modular developments. But not all construction types are created equal when it comes to airtightness and low-carbon construction. Between the drive to reduce carbon emissions associated with the built environment and the necessity to adapt construction sites to accommodate social distancing and COVID-secure requirements, moving processes off-site is increasingly attractive. Although manufacturing timber frames or structural insulated panels in factories is nothing new, these systems, along with cross-laminated timber, open up important advantages as regards to quality control and fine tolerance manufacturing that are key to closing the performance gap between ADT and ABIS. The use of sustainably sourced timber also reduces the carbon intensity of the project, giving a double benefit alongside the simpler process to achieving low energy use. Alongside these panel-based systems, volumetric systems are increasingly finding use, both across high and low-rise sectors. In these systems, fully complete modules with services, membranes and insulation already incorporated are assembled off-site, then delivered and connected into whatever configuration that project requires. What all these systems have in common is the use of off-site assembly, where the more tightly controlled factory environment facilitates closer tolerances and reduces unexpected problems. Particularly when aligned with the principles of design for manufacturing and assembly, which focus on ensuring designs minimize different components and facilitate the simplest assembly process possible. A factory environment makes it far more straightforward to integrate systems and services on a schedule, which minimizes the impact of one process on another. The foundation of all the factors we've discussed today is a well-considered and fully integrated design process. Designers, contractors and suppliers are all working together to ensure high-performance specifications are successfully executed to produce high-quality buildings. Making sure information is available to everyone seamlessly and good communication is maintained throughout the project is key. And with that in mind, we'll now move on to the Q&A session. Good morning, everyone. I want to thank everyone for attending another one of our webinars. And I just want to say thank you so much to you, Sean, for joining us today. That was a fantastic introduction to a lot of different topics, which I personally enjoyed, and I'm sure our audience did as well. So thank you very much. I hope everyone at home is taking care and doing well in the various different areas of the country or worldwide with the challenges we're facing at the moment. We actually emailed out the email address to put questions to prior to the webinar for the first time. So we have a lot of questions today, which is absolutely fantastic. So we will be here as long as it takes to answer those questions. So please feel free to keep giving us more. You can email them to webinar@proctorgroup.com or direct message us on Twitter @proctorgroup. On our webinar page, there is a ton of things you can do. You can ask for a sample pack regarding some of the products that were briefly discussed on today's webinar. You can also download your personalized CPD certificate there and request a Zoom meeting with one of our technical staff. And that page can direct you to a lot of other areas of information to use. So if you'd like to, please go to www.proctorgroup.com/webinar. And there you can actually sign up for our next webinar, which will be in 5 weeks. So it's 5 weeks today on Tuesday, the 4th of December. And that is building refurbishment systems for retrofit and conservation. So we have another special guest joining us then, which is Tim Martin, who is one of the individuals part of the restoration couple, who've done a lot of work on YouTube and project work, really interesting stuff. So he'll be joining us then as a special guest. You will receive a follow-up email to this, which has a link to a survey. If you have time, please fill it out. I read it all personally. The team reads it. We do take the comments and try and utilize them to shape future webinars. So for example, today's webinar was something that came up in a number of the feedback forums regarding zero carbon and different topics that we should cover. That's why we brought in and asked Sean to kindly share his expertise in this particular topic. So we will try and accommodate anything that you think you need going forward. It really helps us if you give us a thumbs up or subscribe to our YouTube channel. So again, if you can, please do that. And I think that's pretty much about all the thematics. So we can just go straight into the Q&A session. So let me just introduce very quickly the familiar faces first. So Pamela Howitt is our senior technical researcher based in Blairgowrie. Morning, Pam.
Morning.
Morning. James Brackenreed Johnson is our technical specification salesman based in Eastbourne, who covers the London area and kind of the whole country at the moment, James, isn't it?
Yes, a little bit. Yeah. Good morning.
Morning, morning. And Ian is our technical director, so he's been with the group for many years, also based very in
Morning.
Morning. And a very special welcome and thanks again to Professor Sean Smith, who is Director for the Centre of Future Infrastructure at the University of Edinburgh. Morning, Sean.
Good morning, everyone, and thanks very much for the opportunity to present. Looking forward to the Q&A. Thank you.
Good. There's a lot of questions for you, so we'll start with you, Sean, if that's okay. This is one that came in by email before, and then I'll start going through the ones on YouTube. Jim has asked, what stages or phases do you foresee that the industry may journey through to achieving net zero?
Well, I think this is the very issue the industry is now looking at, is this pathway and the different stages. And for some of the people I've spoken to in industry, they will focus on almost like a stage one, which is what is the potential regulated energy targets and therefore operational of those buildings. And therefore building fabric now has, whilst it's always been very important, that closing of the gap now becomes a real important parameter. And we'll probably see, particularly in England, the push for combined solar and air source heat pumps with fabric as that first stage, and many have already been undertaking that. The stage two, I think, are what is the other information and knowledge they have in data, and that will be around the construction operations themselves, the upfront carbon, and that could be stage two. And then stage 3 and 4 are basically the stage 3 being the embodied carbon. And there are a number of calculation methods out there. There are some variations in some of the assumptions and softwares. And stage 4 being the end of life. So stage 3, the embodied carbon, has a strong synergy with end of life. But at the moment, there are some products or some systems we don't yet know how to deal with for end of life. So in essence, end of life will always continue to innovate. And that's now starting to be a focus for many universities with the research, whether it's composite materials or other things. So I would suggest there's going to be at least 4 stages, but the first one the low-hanging fruit will be around the fabric and the renewables that people will install and trying to reduce as much as possible the operational carbon.
Absolutely brilliant. Thank you, Sean. And Sean, again, one that's come through in the YouTube feed from Simon. Do you think the perfect has been the enemy of the good when it comes to achieving a low carbon aim?
That's actually a really good question. Being perfect, nothing is perfect, of course, but sometimes if we strive too much into one area, we may actually miss some of the bigger opportunities. And I'm not saying that the energy analysis or energy consumption focus that so many are focusing on with net zero is perfect. The problem with that is if we focus so much on the energy consumption, then coming to those horizon factors I mentioned, will we miss off some of the great opportunities and the great work the industry is doing around off-site design for disassembly and other things. So you speak to some people in local authorities or with industry, and there's just a strong focus on the energy utilization. And if we spend too much time perfecting the energy reduction and energy utilization, energy use, then in fact we may miss a number of these other features. So I'd rather be probably slightly, if I could say, imperfect to that, as close as we can, but then widening the remit into other areas to make sure, because if we think of it this way, as we reduce the operational carbon, then the biggest carbon footprint will be the embodied carbon. If then our future generations are looking to search for materials because of material shortages, the material assets we build now, which we can design for future deconstruction, we leave for them the greatest legacy, which is the greater utilization of the embodied carbon that we've left them as a legacy. All those materials are assets.
Great, thank you very much, Sean. Fantastic. Ian, if I can come to you, Adam has asked, again via YouTube, what about refurb of existing housing stock? Is that something you have a comment
on? Yeah, it is interesting that a lot of the attention is on new build. Sean obviously touched on refurbishment of old banks in the city centres and things, and there is a very good opportunity to refurbish these. The difficulty with refurbishment compared to new build is you're not starting with a blank sheet of paper. You most of the times in new build know exactly what is there. With existing building, you don't know until you take the plasterboard off what kind of condition the wall is in, what conditions the timbers are, the joists, etc. So it's really difficult for people to strive to get the energy efficiency in new build that you can't in refurbishment that you can get with new build. And I think that's why the government concentrates so much on new build. But I think it's a bit unfair to concentrate so much on new build. So I always think personally there is a good relaxation in refurbishment for acoustics in building regulations. And I personally think that there should be relaxations in the thermal calculation for refurbishment as well, similar to the acoustics. So that allows people to still be innovative, use these old buildings, and refurbish them to the best of their ability in terms of energy efficiency, while still being sympathetic to the type of building and the aesthetics of that type of building, and controlling the building envelope, moisture management at the same time. So I think it's a good point. I think we should be concentrating on new build, but I think we should also have something in place for refurbishment, which is sometimes forgotten.
Okay, thank you, Ian. And Jeff has asked Ian, how can APG or Proctor Group, that's obviously someone that's more aware of us, help to close the performance gap?
Yeah, another good question. The performance gap, it's really easy, or comparatively easy, with the greatest respect to architects, to design a building on a sheet of paper. Unfortunately for us, we don't build on blank sheets of paper. And therefore, what looks brilliant on a bit of paper, on a drawing board, sometimes can be really unbuildable. It can be difficult to do, and that performance gap needs to be addressed. And it's it's interesting that it's a big agenda point with a lot of people. So as built-in service, it is really important. I think, to be fair, off-site and modular are doing a great job to reduce that gap. Bricks and blocks is a bit more difficult, but off-site and modular is a great way forward to close that gap, where you can do so much more in a factory than you can on a windy, wet building site starting from scratch. So, in terms of Proctors, what can we do? We do toolbox talks. We've done a lot of work. Our marketing department have done a great lot of work. We've been able to do those toolbox talks virtually because of COVID restrictions. So James and the rest of the team can do these toolbox talks virtually and let them see exactly the do's and don'ts of installing new products. So, for example, our wrap type product is new to a lot of people and it's a new concept. So that virtual toolbox talk can be really useful to them. Along with that, once it's built, we can actually go on site, COVID restrictions allowing, and actually look at the installation, give pointers. That's a good point. You should maybe look at that one, do a bit of work there, and what we call a compliance report. So we'll take photographs and do a compliance report to say, this is good, this needs a bit of work, but you're on the right lines. So we're trying to put that paper to building site continuity there. And I think we're progressing very well with it.
Yeah, I'd agree. Thank you, Ian. Just coming back to the YouTube feed, James, if I can come to you, Cora has asked, and there's a bit of a debate or comments going on about actually air tightness on the feed at the moment, which is great. Cora has asked, should the focus be on air tightness or U value?
Yes, I mean, with how new, in all honesty, air tightness is as a focus in the construction industry, it's always going to be a massive talking point, and everybody will have their own ideas and own requirements and own wants. There's a multiple of different factors involved in both arguments in regards to air tightness and or U value. But to be perfectly honest, both need to be a focus. Everything needs to work homogeneously. It needs to work together in order to make sure that building envelope is performing to the best degree that it can do. As Ian alluded to, in regards to the UK is predominantly on a traditional basis. With the offsite modular coming through more powerfully now, then we're seeing that focus being able to be controlled more from an offsite perspective. You see the tolerances with window openings, with door openings, massively reduced, as opposed to a traditional method where you're looking at sort of, 1 inch to 2 inches gap around your windows, around your doors, which you've got to pack with another material in order to make sure you've got this air tightness layer. From a specification point of view, the breather membranes of years gone by, of decades gone by, the VCLs, they've been a sort of throwaway specification because they were never focused on. They were never looked at from a performance point of view. It was another breather membrane, another VCL. Contract would go to a merchant, phone up a merchant and have this material delivered without paying too much attention in regards to its performances. Because of unfortunate events in recent years, people have looked at these materials now in more depth, and they've seen that there are multiple different performance criteria of these materials. So they're now specific in regards to what they're utilizing, and they specify a particular membrane because they've gone through the rigors of testing that, getting U-value calculations done, whether with Glazer, whether with Woofy. They're looking at the thickness of the insulation, they're optimizing their insulation. But again, you can utilize the insulants in order to improve your air tightness as well, where you're looking at a cavity system. Tape your joints on your boards with an airtight tape, because you've got, again, as we showed in the webinar, you've got the insulation on a rigid basis, which ultimately will shrink. So therefore, those gaps in between those cavity boards will increase in size. So utilizing an airtight tape over those boards will impede that egress or ingress of air through those boards. So it's working from concept to reality. It's taking the designs of the architect and making them come to fruition. So the education needs to be there. The toolbox talks need to be there. The understanding from every different stage, from concept to reality, needs to be there. With Dame Julius Hackett's report, focusing on the fact that everybody needs to be talking. This communication needs to be there for a full understanding, and adopting and accepting the fact that these modern technologies aren't there to cost more money. They're there to future-proof these buildings and make sure that everything that we're living in doesn't have unplanned air movements.
Good. And just another one from the same individual that she's now emailed, actually. Any thoughts on this, James? Should non-carbon neutral products be designed into the building envelope?
Yes, but there's arguments again for both. In regards to the functional high-performing materials that can't currently be made by utilizing zero carbon, non-carbon products, raw materials, then they're providing the performance for that building envelope. So I think, as with Code for Sustainable Homes, until it was abolished, unfortunately, there was the ability to offset. So utilizing your renewable energy sources regarding your rainwater harvesting, treatment plants, so on and so forth, you could offset the utilization of those materials. Predominantly, it was, you were using your extruded polystyrenes, your sort of low on the green guide rating products, or the BREEAM rating products, to offset with those. But as we've seen, even with facades in high-rise, where you've got your A2 non-combustible or limited combustibility materials required, there are exemptions, such as your breather membrane, which still has to conform to a certain level, however, not as high as the facade system itself. So what obviously the hope is that this will be taken into consideration with the future homes, and that there's certain materials which will last the lifetime of the building, and hopefully by that lifetime has expired, then that material will be able to be recycled. I mean, a question to Sean, I suppose, at the moment, I mean, would future homes adopt that philosophy or exemption with certain construction products?
I think it's likely, because there may be more damage by not doing so. When you look at some of the resilience measures, look at the intensity of rainfall that we've had recently. We've got increasing damp, increasing humidity, which is also significantly affecting our pre-1919 buildings built 120, 140 years ago, 150 years ago. And therefore, some of the measures which we'll have to look at may not always have to be natural products, because in fact, the weathering requirements in some areas will require something which is far more durable, and can last the course. And this is something that's come up before in the Alliance for Sustainable Building Products conferences. Obviously, there's a feature around using more sustainable materials where we can, and we should all try to do so. But it's a bit like, if I can use the phrase, throwing the baby out with the bathwater, we may actually create many, many more issues than we foresaw by doing that. So there's a word of caution around that.
And Sean, thank you, James, and thanks for that, Sean. Appreciate it. Sean, another question from Josh. Given the significance and scale of, in future, many offices being converted to residential, what do you think this might mean for city centres, refurbishment work, energy efficiency, and carbon?
Yeah, it's a good question. I think one of the features around the retrofit side of things, and coming back to what Ian Fairnington was touching on earlier, the big win is in the retrofit of the existing buildings as opposed to the new build. Whilst we want both to move together, certainly it's the retrofit that has to move faster. So with the office conversions, there's a real chance where they're coming into being residential or other types of accommodation or other uses, to reignite parts of these city centres and town centres, which just now and in the future may not have the same influx of people in the normal working periods for offices, as more and more people are working at home. And so if you're in the local authorities just now, one of the big discussions that's going on is, well, how will we regenerate parts of these city centres? How we get that flow of people coming in? And therefore, the potential conversion of office blocks into residential, given the housing waiting list we've got, given then the energy efficiency measures you apply to those office blocks, it could be a double win of reigniting the city centre heartlands or town centre heartlands and striking at the energy and carbon reductions that you'd want to achieve. And in terms of speed of delivery, it's faster than the new build. So in essence, if you've got significant housing waiting lists, if there's opportunities to create the 1-2 bedroom studio flats which are in desperate need, and you're regenerating your town centres, then fantastic. You can actually do all of that together. And the other thing is that city centres have that nightlife economy. That needs to be sustained. How many people went to the office, went to work, and then afterwards, every so often went to the theatre, went to the cinema, went out? If those people aren't still going into town, you're going to have to replace that. So we might see some local authorities really accelerate and support planning applications for conversion of office buildings to get more people back into the city centre quicker.
Great point. We might just have to wait for the theatre, maybe 2021 for the theatre, but yeah. Pam, a couple of good questions around materials here. So I'm going to come to you on these. It's one of your areas of expertise. Tony K has asked, are we able to confirm if there's any plan to recycle our products at the end of their life?
Yeah, I mean, I think James has touched on it and everything that's been mentioned. Currently, there's a lot of parts of our products that can be recycled, such as the easy one is the timber in our acoustic battens and our acoustic products. But unfortunately, we are often limited as to what we can recycle due to the current limitations in what can be recycled. So there's a lot of recycling centres, there is a lot of development in those areas, but a lot of the materials that are used can't be recycled, be it because they can't be separated easily or just easier to chuck it all in a big skip and forget about it. The technology sometimes isn't there, but again, they're working on it. Hopefully, that by the time that the buildings that are being built now are getting dismantled, the technology for that recycling will have caught up, and that we'll be able to recycle and reuse a lot of the materials that are taken out of them. And it's exactly what Sean was saying in his first question there about end of life driving innovation now.
Okay, great. And another one, just material-wise for you, from Carol, are plastic-based materials not something we should be stopping using and moving on to more natural materials?
Yeah, again, we get this quite a lot. It's like, are you not looking at natural materials, etc.? I think we have to look at it that not all plastics are bad. There's an awful lot of plastics that are used in buildings. They're not considered single-use plastics. So it's not like going to grab a bottle of water off the shelf of the supermarket when you're thirsty and then throwing it away when you're finished. These membranes, these sealants, gaskets, components, they're all intended to last a long time. The lifetime of the building, it could be up to 60 years. And they're not designed just to be used during the construction and thrown away again. I think James touched on it earlier on as well, in that as much as we would like to use natural materials, Sean said it as well, sometimes they just can't perform the function that we need them to perform in the building. So it's impossible to fully remove them from your structure and still be able to keep the water out, keep your heat in, drain it, do all the things that you need to make your building work properly for the occupants.
Good, thank you, Pam. Sean, if I can come back to you just for a general comment on some of the activity that's going on in our feed. Earlier, there were a few individuals talking about the planning and understanding of people involved in projects between the requirement for airtightness versus ventilation, how that works in practice. And there's a few more comments coming through now regarding COVID and ventilated areas being important, and how people may be affected health-wise. So if there's any comment you have around that kind of topic of, the perception that airtightness in buildings can be bad, and is ventilation misunderstood, or is airtightness misunderstood, what can we do to make sure all parties understand?
Well, it's a very good question given the situation, and I think it's a big feature, particularly moving away from housing, for example, just in theatres and other things. If anyone's not seen it, there's a very, very good video which was released by El Paz, the Spanish newspaper, on COVID, and some research that's been done in Spain on how the COVID particles move around depending on the number of people in the room and the lack of airflow. In relation to buildings per se, well, we've always felt and we've always known that if we do go for more airtight buildings, we have to use sort of say ventilated and MVHR type approaches. And that's one of the other discussions that's come up more recently, is about the incorporation of MVHR in respect to the net zero and where that's going, and the energy reductions. There will be those who would much prefer to have a naturally ventilated building. I have my own thoughts on various things, which are my thoughts, not the University of Edinburgh, so I won't bias the conversation. But my personal view, and this is my personal view, is I'm not a fan of airtightness absolutely to the tree. I would rather have it with the flexibility that we can come in so far. If we get really good fabric to a point, that may be sufficient. And we know that some people who have moved into very airtight homes certainly weren't, and that's training, that's behavioural change of how to adapt and live in those homes. And with the best will in the world, you can issue sort of all sorts of guidance and videos and other things, but people will often go back to the usual way of how they did things. Now, that's not to say it shouldn't happen, but I think we need to be conscious. It's about putting for example, only natural-based products in buildings. Would that actually create a bigger carbon footprint because of the extraction of those materials at a later date? Similarly, if we go for very airtight and people are not using or switching on the mechanical ventilation as they should be, is that then going to lead to other issues? It's a really fine balance, and there are sides to, there are camps on both sides of that field just now. And I would just ask everyone to just consider one thing. We are seeing increasing levels of humidity in the external environment with the intensity of rainfall and various other things which are happening. Perhaps we might need to adjust how we look at very airtight buildings, or the rate of airflow for the MVHRs. Do we need to step up that rate of airflow in the MVHRs if we're going very airtight? So I'll leave that to others to do the science and come back to us.
Good. Okay. Thank you, Sean. Just one here, Sean, as well on the type of modern methods of construction. Casper is wondering, so of all the modern methods of construction, so SIP, volumetric, etc. So this is something that Proctor Group, we're actually quite heavily involved in these. So interesting for me as well. Do you see a clear winner emerging, or will there always be a mix?
I wouldn't bank on one particular. I think there's a good mix. We've seen some really good systems which are closed panel timber systems. We've seen some really good modular timber and steel systems. So in essence, we don't see one jumping beyond another. I think when it comes down to looking elements around the net zero, I think maybe some people may look at the modular in the future, maybe not now, but probably move more towards the modular with some of the net zero benefits that may come from that. But certainly it's great to see the industry doing so much. We've got the training academy, I know in Scotland, through Offsite Ready at the Construction Scotland Innovation Centre. You've got the organisation for Build Offsite for the UK, which is really championing. You've got many house builders that are adopting more and more offsite type systems. So in essence, it may not be the whole house, but I think there's benefits all the way around. And one of the things, coming back to points made by your colleagues earlier, the business to business, where if you can actually have your membranes or your insulations or your other products going straight to be installed in the factory, then that can really help reduce versus the normal traditional open approach on site. It can really reduce some of those gaps which can appear, in particular around the energy performance.
Absolutely, and I agree. I mean, we're certainly seeing more and more of that, of products being installed, off-site. Of course, traditionally with timber frame, that's been the case for a long time now, but with the volumetric stuff. And actually, on this one, Pam, I'll just come back to you. Joseph has asked particularly, so why are products being, like Wraptite, being adopted for these off-site and modular builds? Anything to add?
Yeah, I mean, one of the major benefits that we've covered in numerous webinars now is the fact that Wraptite can be fully adhered to the substrate. It's fully bonded. I know it doesn't sound much of a unique selling point, but where it can be installed in a factory, as Ian touched on earlier, in well-controlled conditions, dry conditions, clean conditions, that can come out the factory as a fully protected unit. And you can wrap all sides of those units with the Wraptite. This then allows it to be stored on site until it's transported to site, keeps the internal fixtures and fittings dry, and allows any moisture that's in there in the construction phase, which is minimal, to dry out. Really keeps the damp out of it. The real benefit when it comes to transportation is because it's fully bonded, there's no way of wind and air to get in behind that membrane, which can then cause damage to it during transportation when it's heading up the motorway or across country. This means that once it gets to site, it's still well wrapped, it's not damaged, it needs less in the way of patching or repair work or total replacement on site. And it's arriving really in optimum condition, looking smart, looking like a quality system. The other real major benefit to it is the fact that with wrap type being vapor permeable, it can be considered vapor neutral. So it doesn't matter if you fix two faced sides together, it won't prevent moisture from moving, and it won't trap moisture on the wrong side as you might have if you use something like a vapor control layer or something that could trap moisture within the construction, and it also provides your good levels of airtightness for the finished building.
Good, thank you, Pam. Just went to the YouTube feed on the back. I think, well, Ian answered this a little bit regarding the upgrading of the existing housing stock, but perhaps more relevant for you, Sean, just on the back of what you were talking about with offices potentially refurbished into residential properties. Mark has said, a lot of the existing building stock, especially in town and city centres, they're historic or listed buildings, and obviously quite close to protected, which can be a barrier for upgrading. Are you seeing changes within local government authorities to relax limitations?
Is that for me?
I think so. Yeah. If you're happy to comment on it, Sean.
I've not really seen much of a change as regards to any influence on the listed status. There are already measures within quite a few of the building regulations where if it is a listed building or a historic building, there are reductions or less onerous requirements around some of the building regulations performance, with the exception being fire. But in other areas, whether it's related to parts of energy, acoustics and other features, there's a slight reduction in expectation of what may be achieved. In essence, they are fantastic legacies that we've inherited from our previous generations, some of these buildings, and it's great when we can see them being brought back to life under new uses. So I very much hope that we continue on that trajectory where we do bring these buildings back. And many of the construction products which are out today can be used with these historic buildings. We've learned over the last 20, 30 years what works best. So I think there's a good opportunity there. I really do. And I hope more of us will make the most of that.
And just additionally, sorry, Ian, go ahead.
We were involved in a European research project for, I think it was 3 years, where we were part of a refurbishment work task. 16 different members from different countries throughout Europe we used to meet. And one of the tasks was to improve the thermal efficiency of historic buildings while being sympathetic to them. Our particular task that Proctors were tasked with looking at was trying to develop an insulation that could be injected in the small space behind the lath and plaster and the solid wall. Now, you would think that's quite easy, just fill it with foam or mineral fibre. But some of the parameters that were put on that was fire performance, breathability, water resistance, and maximising the thermal benefit. Now that would lead us towards one of our products called Space Therm, which ticks all the boxes there, but it's difficult to inject in between that lath and plaster space. So our task was to try and come up with a blown-in Space Therm, essentially. And we have done that. We did it very successfully. We used BCA in Glasgow to do the work. We used the existing technology of the blowing machines. We had to cut the space therm into 5mm cubes to then maximize the space filling ability. It got very good breathability, got very good water resistance, got very good fire performance, and it filled the gap better than any other insulation that BCA had ever used. The difficulty, though, as many of the viewers on this program will tell you, is the price. And the price was really expensive. So it wasn't, from an academic point of view, it was a fantastic bit of research. But the problem was, and this is always the problem with product development, is coming up with a product that actually meets the market requirement in terms of price. So you hit all the other boxes, but the problem was this was a fantastic product, but not many people could afford it.
I think you're right, Ian, because there's obviously a defined price point for what is a very commodity solution that's out there already. What you're doing is introducing something which is so difficult to commercialize because it's so far away. And you've almost kind of answered a question from Mike here. Does there need to be a change of culture and conscience within the industry towards new plant environments from traditional building mentality? So we're very much stuck with the sort of view that things should be done as they've always been done, and they should be done at the same price point as they've always been done. So that's been one of our main challenges at Proctor Group, because we do have these class-leading, often more expensive products where we have to show the value overall rather than just square meter price for the installation price overall. So I think that kind of answers what Mike's saying.
Yeah, I think it's a balance between saving the planet without sounding too grand and saving money. People's perception differs depending on the economic climate. So I think people might be more concerned about the climate just now, but depending on what happens with the offset of COVID in a recession, money might take over the climate. And it'll be really interesting to see where that actually ends up. Both are really good things to look at the same time. And we're always looking for that golden nugget in our product development that hits both. And then we've won a watch, but it's not easy.
Mm-hmm. I've got two questions here, Ian, around membranes. So one is a sort of generic one from Cameron. How can membranes be further enhanced? And can I also add another one here from Scott? So one is just around general membranes and how can they be enhanced? The other that links in with this, is a breathable membrane able to bridge the gap? So in terms of ventilation, would a breathable membrane be a way to passively control ventilation? It's a good one for you, Ian.
Yeah. If we deal with what we're doing with membranes in terms of enhancing them, that's what we do. We always look for what is the new technology that we're looking at. Should we put a self-adhered membrane on it? UV resistance, what's the climate change going to be? What's its weather resistance going to be a requirement in the future? It's okay just now, but what happens with intensity of rain? Do we need to increase its breathability, vapor permeability? And its air tightness is important as well. So we're constantly looking at new technologies. We deal with manufacturers to see whether they've got new technologies that are used in other areas. At one stage, it was suggested that the non-woven fabric could be, an aromatherapy could be put on the non-woven fabric, which was used in washing machines, and the fabrics there. Now, to us in the construction industry, whether it smells of heather, the roof shield, might be a nice thing, but we didn't think that was necessarily what the market wanted at that particular time. But you're never sure. When we were able to change the colour of our frame shield for timber frame buildings, that had an ability, but we never thought that the market would be interested. But we went to the market and said, by the way, we can get this any colour you want, specifically for you. And shock, horror, they were able to do, the timber frame manufacturers wanted their own colour. So we have to speak to the manufacturers as well and speak to the market to come up with But we're constantly looking at new things. Fire resistance is obviously very important just now. Wi-Fi connectivity, should you put that in the membrane? That's really important potentially. And heat loss as well as moisture control. So there's lots of things we're looking at constantly. And it's causing us quite a lot of sleepless nights sometimes.
John, did you have something to add there?
Yeah, just briefly, I think the way that we're going with the price of sensors coming down, the ability to have those sensors embedded, but also what's happening with Li-Fi and other things where we can actually now take so much of the different technologies together. If we did move to very airtight homes, then it could well be that your house would then have just a small monitor to alert you if humidity levels are high, if your CO2, or of course with carbon monoxide levels as well, we have sensors for that. And therefore, actually, that could really help people if we do move to, consistently always very airtight homes with MVHR and a kind of passive type approach. The ability of these sensors to then alert people would be useful. Of course, you need to see and hear the sensor in some shape or form. And we've seen with some of the real-time energy monitoring devices, the visual displays, that if people put them under a stair or something like that, then they can't see them. So perhaps it will probably go to your phone or something like that. But that would really help the sector, because instead of just preaching to people who are moving in, this is how you live in this home, the technology might actually help them understand how to just utilize the environment as it changes in the home, so they can adapt to it.
Absolutely. Thank you, Sean. So I'm going to come back to you, James, for one more, and then back to Sean for the last 2 or 3, 4 questions. So if you have any more, please post them now on YouTube or email them to us at webinar@Proctor Group. So we'll keep going as long as the questions keep coming, presuming, Sean, you have the time. I think people are enjoying this, so that's great. So James, I haven't forgotten about you. There's a question here regarding airtightness in terms of why is the UK so far behind in its airtightness requirement?
Right. Again, I think it's been alluded to sort of throughout everybody's questions and answers. I think it comes down to the fact that this is the UK. We're very traditional about the way we think. We're sort of marginally frightened of new and befangled things, especially if it costs more money. So from a design point of view, obviously, I mean, it's ever encroaching. The airtightness thought process from a design stage is increasing, as I've mentioned before. But it's about translating that down to the contractors and making sure that they're aware of what needs to be achieved. If you look at sort of parts of mainland Europe, their air passivity as a standard is between between 2 and 4. So even with our enhancements that we're doing in the consultation in 2020 or 2021 at this stage, most likely, we're still not there yet by any stretch of the imagination. Don't get me wrong, there are projects that I'm working on now that are working on achieving below 1 on their air exchange, which is great. This is the contractor, the client that's pushing it. So there are people out there, they are making themselves known in regards to pushing this forward. But ultimately, we build in a traditional manner with brick and block. So it's looking at all the different avenues that we can go down with the volumetric side of things to make sure that we are approaching it to get this air tightness requirement down. If you look at the insulation, which is predominantly where architects, where contractors have been focused in achieving a low U value, the problem that we're facing at the moment is the saturation point, the law of diminishing returns. The material, the insulation is getting to such a point where you're either encroaching on your internal usable space to get as many plots on site as humanly possible, not talking about not talking about national house builders at all, trying to get as many plots on site as possible by encroaching on your internal usable space, or you go the other way and increase your footprint size, which ultimately means more materials in order to increase your footprint size, more costings anyway. So looking at that air tightness to control that footprint size, it's, as you alluded to before, it's not about the cost of the material that's enhancing the performance of the building. It's that overall impact that expensive product has on the building envelope itself and the performance of it. So it's not looking at a spreadsheet and saying, right, that costs £450, this costs £320, let's go for that one. It's looking at the building envelope as a whole. It's looking at the building functionality as a whole and identifying the fact that the overall build costs after the build is complete, the overall speed of build will be less. So therefore, that more expensive product all of a sudden comes into a world of its own. So yeah, the UK is far behind, and even with the new enhancements on that to 8 as a backdrop instead of 10, it's still going in the right direction. But it needs the education from a design point of view, from a main contractor point of view, from a subcontractor point of view, to negate the performance gap. Not the performance gap of the building, but the performance gap of the contractors, the installers themselves, so that their understanding of what they're doing and how well they need to do it is there.
Great, thank you very much, James. John, just on that, last 2-3 questions for you, if you don't mind. Regarding the internal space provisions, we had a question on this from Claude. Just, are there any policies to ensure a low carbon future does not sacrifice quality of life, i.e. things like internal space provisions, natural lighting?
Well, we've certainly seen more public bodies ask for the reintroduction of space standards to be part of the development process, and some local authorities are doing that. That would certainly counteract some of the issues which have gone on. That said, you know, the population is rising, and you saw at the start of my video just what's coming in the next 10 years alone in England and in Scotland, let alone, you know, globally over the next 80 years. So there has to be a balance with creating the right spaces as we move into these low carbons. That, coming to James's point, it doesn't encroach too much on the internal footprint and operational use and occupant use of the building, but at the same time is attractive to people. I mean, whether you're refurbishing, whether you're building new build, you want something which is practical that people can live in. And if we make the walls too thick, or we put so much gubbins of technology into things, when it's been shown in many studies, in fact, most successful low carbon homes are really done with the fit and forget approach. Put as much as you can into the fabric. Don't expect the occupants to be having to follow technologies and meters and other things all the time, and there's a balance. So I think that would help and work out in the long run, but it's no easy task.
I bet. Okay, here's an interesting one from Natasha. Can you outline the practical differences between net zero and zero carbon buildings in very simple terms? So like she's 5, so very, very simple terms.
Okay, so let's think as net zero is basically a balance, like a weight of scales that we used to have in a butcher's shop or in a baker's, wherever else. We're going to have so much carbon that we're emitting, and we're going to need to have to offset that. If we can reduce that amount of weight of carbon in our operational and our build, then the amount of offsetting also then reduces. But overall, it's a balance. That's your net zero. Zero carbon is implying that something is delivered which has zero carbon content or entity. And I think this is where the definition of where we're going with net zero becomes important. So the open anticipated use of net zero is that balance approach. And I think the Advertising Standards Authority hit the nail on the head by the use of the terminology zero carbon really couldn't be used probably for the vast majority of products, because carbon was utilized in the manufacture and transport or some other measure related to it. So I do, when I'm speaking to my research colleagues, when I'm speaking to public sector and industry just now, and we're talking about this, and I hear them saying zero carbon, immediately I have to say they're probably wishing I wasn't in the room, because I immediately go, there is no such thing as zero carbon. So can we just park that and let's focus on net zero at the moment? And when technology becomes good enough and we can demonstrate that we can get a zero carbon, then great.
Good. And one around government funding from Neil. He's noted with sense of frustration the lack of leadership from government over their need to deal with existing buildings. So something we've talked quite a lot about today. The Green Deal, widely recognised as a disaster in his opinion. Are you aware of any plans to fund this huge undertaking?
I'm not aware of any immediate plans to fund. We know that on the new build side, some parts of the UK and some local authorities offered incentives to go to whichever level of sustainability. We know in Scotland, if you went for silver or gold, there was a small sort of additional payment or grant that went towards that. It didn't cover the cost of the difference, but it was a contribution. When we look at the existing stock, the first push that's coming down the line is in the private rented sector. And they're going to have to move really quite quickly. I mean, you look at the scale of what's to come right across the UK with the private rented sector having to achieve various EPC band levels. Now, there's a separate discussion, actually, the value of what is an EPC band level in real life with all the things that you can do. But well, we'll leave others to argue that. But nevertheless, it's giving us a pathway. It may not be perfect, but it's a pathway to try and look at these improvements. Now, what's to say that as part of the Green Deal or other opportunities next year, once the government knows, it's only doing a one-year government finance model this year, once they know next year, probably by the summer, what was the balance of the COVID outfall this winter in terms of the economic impacts, will they then maybe probably look at, could they incentivize this further, as they did with EV charging points, where you got a grant towards that and other things. We saw it with the FITs, the feed-in tariff. But a game changer in terms of carbon reduction overall would be a grant mechanism, not a loan, but a grant mechanism on the retrofit of existing buildings to improve the energy efficiency. That would be a tremendous drive for the market to help. Now, that's the actual value. I'll let the financials and accountants work that out. But we've seen in other areas, if there's a financial incentive rather than just always a stick, it really helps.
Okay, good. Right, last two, Sean, I promise. I'm sorry, they keep coming through and we just want to answer everyone while they're still asking. Quite a specific question on the digital twinning issue from Rob. How important in your view will it be to ensure that information about construction products is current and accessible? And he goes on to say, have you any thoughts on the proposals to incorporate digital object identifiers for construction products where key product information is held externally by registration agencies and is guaranteed to be available for the lifetime of the building and beyond?
It's an excellent question. We had a discussion for 2 hours, well, almost 2 hours, between colleagues the other day, because we're leading one of the largest European projects around digital twinning, the integration of BIM and the integration of then into the retrofit sector. There are like 9 countries taking part, and the UK has got, and the University of Edinburgh has, I think, one of the largest parts of that. The absolute holy grail, if I may use that phrase, would be would be for us to use the learning of that object repository information, which then has the carbon footprint, the material sources, where it all came from, which is then dropping into the BIM model into our digital twin. And at that point of when the building is built or retrofitted, coming back to the Dame Judith Hackett points, the drawings and evidence which is finally submitted to building control, the digital model, is this is the as-built. And with that as-built comes all of that data and information related to the products that are in it. Now that really helps us not only with understanding the embodied carbon, but for our future generations who probably won't have YouTube because there'll be some new technology in 150 years' time and they won't be able to watch this. But if they were, they would hear us say, we need to do this now so that that digital data model in 100, 150 years' time is accessible for them to then look at how they will use those existing materials or assets, or maybe they'll retrofit the buildings we build now in 100 years into some other technology or utilization. So it is all interlinked. If there was, through some sort of planning requirement, that which whether it came through the Land Register of Scotland or the UK, the English Land Register, that when those buildings are built or deposited, it comes into that sort of central database, it would be great. Just one thought. We have been retrofitting buildings all over the UK. I say we, the industry. There is no central record in a digital repository record of which ones had blown fibre, which had 200mm insulation, which had whatever cellulose-based insulation. There is no central record of that, which is quite worrying, because there's the very first case why you would want to have a central record so you could track. And then sadly, of course, we've seen people then demolish a house without knowing the cavity walls had been filled as part of a retrofit, and the insulation material is then scattered everywhere during that demolition.
Okay, last question, I believe. So from Sebastian, Sean, is there a broad enough consensus around the Horizon Net Zero concept to reduce the risk of multiple competing standards emerging?
It's a very good question. So I think my view would be that we stay with net zero, but we incorporate in our procurement and our thinking and our planning about these horizon factors. For the very reason, if we just chase energy alone, as I said earlier, then on the net zero, then we will in effect create more problems than benefits. And the biggest carbon benefit is actually the future benefit of knowing what's been built and having that digital repository, the ability to deconstruct it at a future date. So net zero is here to stay. What will be in net zero, we're now waiting for the governments to tell us what they want and how they want to define it and which of those international standards they would like us to use, and the TC 350, etc. That would be great. And maybe by COP26, which is in Glasgow next year in the UK, perhaps that would be the major announcement. We will now finally know what is the specificalities of net zero, because if we don't know that now, I'm just looking at a very good presentation by a professor at the University of Cambridge recently who was talking about the energy portfolio for the next 50, 60 years and what we need to do. He was also saying, unless we know very soon, one, the definition of net zero, what will be incorporated, and what decisions we intend to make around green hydrogen, electric vehicles, and various other features in policy, then sets the trajectory for the next 10 to 15 years. So we need that sooner rather than later. And so my feature around horizon factors, whether we call it horizon net zero, whether it's net zero with, please incorporate also consideration to horizon factors, it would be a great step forward in my opinion.
Thank you very much, Sean. Good, okay, that wraps up quite an expansive Q&A today. So well done everyone. Thank you very much, Sean and the team. As always, great job. Thank you very much indeed. Apologies we don't have a normal Proctor logo today on the Zoom call for some reason, and I understand my audio's been a little bit dodgy. I've got a new laptop, so it just shows you that newer things aren't always better. So we'll look into that. For our next webinar, which is 5 weeks today, so 10 AM, Friday the 4th of December, so same time. The topic is building refurbishment systems for retrofit and conservation. So it's featuring a different special guest, Tim Martin of the Restoration Couple. Now, if you haven't seen these guys on YouTube or their social media, have a Google of it. It's really interesting. Fantastic buildings and some great work they're doing. So we will be talking all things retrofit surrounding conservation and of course restoration and refurbishment, which I'm really looking forward to. After this, you will receive an email to a replay. Please circulate it to friends, family, anyone you think may be interested in this, out with the construction sector as well. I mean, our main audience is within construction, but this is quite topical, so I'll certainly be sharing this with others. You also will receive a short survey. Please fill it out if you can. It does help us hopefully present more informative and better quality webinars for you as we move forward. If you give us a thumbs up or subscribe to our YouTube feed, it really helps us. So please do that. And I just want to thank all the attendees of the webinar. The 4th of December will be our last one for the year, but for me, it's been a fantastic year of the company and the team putting these webinars together, and a real focal point for our business during the pandemic. So it's been very enjoyable and very successful. So thank you for continuing to attend. We really appreciate it. And I hope you have as nice a weather as we do here in Perthshire today. Not seeing rain, which is very odd. So please enjoy the sunshine wherever you are if you have it, and have a fantastic weekend. Thank you.